Air travel shapes our world. Every day, millions of passengers cross continents, goods move faster than ever, and economies rely on aircraft to stay connected. At the heart of this global network are two titans, Airbus and Boeing. Their rivalry is more than corporate competition. It is a clash of philosophies, engineering approaches, and visions for the future of flight. From design to cockpit, automation to pilot control, these two companies represent very different paths to the same goal: building aircraft that are safe, efficient, and capable of connecting the planet. Understanding their differences offers insight into the very mechanics of modern aviation. Boeing, founded in 1916 in Seattle, began by producing wooden aircraft before transforming into a global leader in commercial aviation. Iconic models like the 707, 747, and 787 Dreamliner showcase Boeing's emphasis on pilot authority, incremental innovation, and evolutionary design. Airbus, established in 1970 as a European consortium, was a bold answer to American dominance, focusing on collaboration, standardization, and system optimization. From the A300 to the A350, Airbus has consistently applied these principles, challenging Boeing while shaping global aviation standards. To grasp why pilots, airlines, and enthusiasts often debate Airbus versus Boeing, we need to explore 5 major differences between their aircraft. 1. Flight control systems, fly-by-wire versus pilot-centric feel. One of the most noticeable differences between Airbus and Boeing aircraft is their approach to flight controls. Airbus popularized fly-by-wire technology in commercial aviation. In this system, pilot inputs are transmitted electronically, with sensors, computers, and actuators adjusting control surfaces automatically. Fly-by-wire allows Airbus aircraft to enforce envelope protection, preventing dangerous maneuvers such as exceeding stall angles or overspeeding. This design prioritizes predictability and safety, reducing pilot workload and enhancing automated performance. Boeing, by contrast, emphasizes tactile control. While modern Boeings, like the 777 and 787, also employ fly-by-wire, the system preserves control feel, giving pilots direct feedback through the yoke. Boeing's philosophy centers on pilot authority, allowing skilled operators to make nuanced adjustments in real time. During turbulence or rapid maneuvers, Airbus may subtly limit extreme inputs, while Boeing lets pilots exert more direct influence. This distinction affects training and operations. Pilots moving between Airbus and Boeing must adapt to control philosophies, which can change how they manage a flight. Passengers might not notice, but pilots feel it every second in the air, and airlines consider it when assigning crews. 2. Cockpit layout and human-machine interaction. Cockpit design reflects each manufacturer's approach to human-machine interaction. Airbus prioritizes standardization. Across models from the A320 to the A350, cockpits share layout, displays, and systems. The side-stick control, glass cockpit, and automated flight management reduce workload and simplify training. This consistency allows airlines to operate mixed fleets efficiently, as pilots can switch models with minimal retraining. Boeing's cockpit philosophy is more evolutionary. While automation exists, it complements pilot input rather than replacing it. Cockpits differ across families like the 737, 777, and 787, emphasizing pilot authority, tactile feedback, and intuitive design. Boeing maintains familiarity within each model's lineage while allowing gradual technological innovation. Pilots describe Boeing cockpits as organic, where experience and intuition play a central role. These philosophies influence airline choices. Airbus offers operational efficiency through standardized cockpits, while Boeing appeals to pilots who prefer hands-on control and evolutionary familiarity. The differences extend beyond aesthetics, affecting training costs, safety, and operational consistency. 3. Aircraft design philosophy, efficiency versus human-centric innovation. Airbus and Boeing approach aircraft design differently. Airbus focuses on system optimization, integrating aerodynamics, materials, and automation to maximize efficiency and reliability. The A350's extensive use of carbon fiber composites reduces weight, increases range, and lowers fuel burn. Airbus views each aircraft as a system where technology works cohesively to improve performance. Boeing balances innovation with pilot-centered design. The 787 incorporates composites and advanced avionics, but the company emphasizes how the aircraft feels to the pilot. Controls are responsive, and manual input remains central. Boeing evolves designs gradually, retaining pilot familiarity while introducing technological improvements. These philosophies affect both operational and passenger experiences. Airbus aircraft may achieve slightly better fuel efficiency, while Boeing aircraft provide a more hands-on, responsive flying experience. Both approaches reflect solutions to the same challenge, creating safe, reliable, and high-performing aircraft in a competitive market. 4. Aircraft family strategies: standardization versus evolution. Airbus structures its families to maximize standardization. Cockpit layouts, avionics, and operational procedures are consistent across families like the A320, A330, and A350. Airlines can operate multiple Airbus models with minimal additional training, reducing costs and simplifying logistics. Standardization accelerates adoption of new aircraft, as pilots and maintenance crews are already familiar with the systems. Boeing, in contrast, takes an evolutionary approach. Its 737, 777, and 787 families retain core design elements while integrating new technology incrementally. The 737 MAX introduces new engines and avionics while remaining consistent with prior 737s. The 777X adds folding wingtips and composite wings, but maintains familiarity with earlier 777 models. Boeing's philosophy emphasizes continuity, ensuring pilots experience gradual transitions while adopting new capabilities. These strategies affect airline operations. Airbus allows fleet flexibility with minimal retraining, while Boeing prioritizes continuity, pilot familiarity, and evolutionary improvements. Both approaches are effective but reflect fundamentally different philosophies. 5. Market philosophy and global strategy. Airbus and Boeing differ in their market approach. Airbus, as a European consortium, focuses on collaboration, system efficiency, and standardization. Its aircraft appeal to airlines seeking fuel efficiency, global consistency, and technological integration. Airbus invests heavily in emerging markets, producing aircraft like the A220 for short-haul, high-frequency routes. Boeing, as a US-based company, emphasizes technological performance, incremental innovation, and brand loyalty. Its aircraft target long-haul premium travel segments and business aviation. Boeing's strategy integrates pilot preference, evolutionary upgrades, and proven reliability, appealing to airlines seeking incremental improvements without drastic changes. These differences extend to after-sales support, maintenance programs, and financing solutions. Airlines consider not only the aircraft, but the ecosystem surrounding it, including pilot training, spare parts, and global support. The strategies of Airbus and Boeing reflect broader global philosophies and influence how fleets are managed worldwide. Looking forward to 2026 and beyond, as we approach 2026, both manufacturers continue to innovate. Airbus is exploring electric and hybrid electric aircraft, advanced digital cockpits, and sustainable fuels. Boeing focuses on predictive maintenance powered by AI, next-generation aerodynamics, and pilot-friendly technologies. Both companies are preparing for a future where automation, sustainability, and efficiency define commercial aviation. The Airbus versus Boeing debate is not simply a corporate battle, it is a story of human ambition and technological evolution.
Airbus emphasizes automation, standardization, and system optimization. Boeing prioritizes pilot authority, evolutionary design, and tactile innovation. Together, they have pushed aviation to new heights, from the first commercial jets to today's fuel-efficient long-range aircraft. For enthusiasts, content creators, and aviation professionals, understanding these differences offers a window into the mechanics of modern flight. A series tracing Airbus and Boeing, from early models like the 707 and A300 to the 787 and A350, can highlight engineering philosophy, operational strategy, and technological innovation. Combining history, technical insight, and market perspective makes aviation storytelling compelling. Ultimately, the Airbus versus Boeing debate is not about better or worse.
It is about different approaches solving the same challenges, creating aircraft that are safe, reliable, and efficient. Each innovation, aircraft, and operational decision reflects decades of human ingenuity. From flight control philosophy to cockpit design, from aircraft design to market strategy, Airbus and Boeing demonstrate that multiple paths can achieve remarkable results. By 2026, the next generation of aircraft will be smarter, cleaner, and more efficient than ever before. Yet the lesson of history is clear. Innovation thrives when competition pushes boundaries, and human ambition continues to reach higher. Airbus and Boeing have defined modern aviation. Their aircraft, philosophies, and innovations influence how airlines operate, how pilots fly, and how passengers experience flight. From system optimization to pilot-centric innovation, from cockpit standardization to evolutionary design, Airbus and Boeing show that rivalry drives progress. As aviation embraces electric propulsion, AI-assisted flight, and sustainable fuels, both manufacturers will continue to reshape what is possible. The sky has never been the limit. It has always been the beginning.